Right gang, welcome to another mechanical science video. Now this is going to be a video in a series relating to fluids, but before we can start to sort of investigate fluids, I wanted us to visit this word here, or this terminology here. Okay, in particular density, and we'll touch on relative density as well. Now this is, as I said, it's going to tie in with lots of fluid stuff that's coming up, and you can see some of the formulas you're going to have to be able to manipulate to get your head around formula, to get your head around fluids, and also start to answer some of the questions for your upcoming exams. But what we're going to do today is sort of look at this formula here. Okay, now you can see a little GIF there of some different densities taking shape, but more of which in a moment. So okay, so what is density? Now you might have come across this word before when you've been doing science at school. Everybody's heard of the word density, but not a lot of people know what it means and how to calculate it. All right, now as I said, this is going to be tying in with some fluid stuff, but we're going to start off nice and easy, and we're going to have to look at some solid calculations. Solid, I don't mean hard. I mean calculating density of solid objects to start off with. Okay, but before we do that, we're going to have to get our head around the actual formula itself. Now, this is the symbol used to represent density, and it's not a P, it's actually the Greek letter rho, R-H-O. Okay, now you may see it written in some books, it's got more of a sort of accentuated tails thing going on, but on here, it looks like a P and into italics. Okay, next bit, we've got M. No rocket surgery required here, but that M is representing mass. Then the V is representing volume. Okay, so let's have a think. What units have we got for density? So going back to units, one of the things that keeps tripping us up. So mass is in kilograms, volume is in meters cubed. So you've got it. So the density is equal to kilogram meters cubed. Okay, now please bear this in mind here. This V is a capital V for volume, not a small v for velocity. And this is one of the things that gets people confused when we're talking about in fluids. But keep your eye out for some upcoming videos on fluids where we do use a V for velocity as opposed to volume, but I'm going to keep our wits about us as always. Okay, now what we've got here is we've got just a nice neat table of some common densities. Alright, so fresh water has got a density of 1,000 kilogram meter cubed. Salt water, because it's got some minerals in it, the density's a little bit bigger. Now all of these densities that we've got here are approximate, because as we know, some salt water is more dense than others. Yeah, some oil's denser than others, and then obviously I've got some examples of more sort of solid objects as you work our way through, going through to some really dense materials in gold. Okay, 19,300 kilogram meter cubed. All right. Now, if we were to have a think about what this would actually look like, if we had a volume per meter by a meter. I've got one there. Alright, or fresh water, the density of that would be 1,000 kilogram meter cubed. Alright, so that means the mass of that would be 1,000 kilograms. Okay, so trying to visualize that, you've got a block of something, it's a meter cubed, that's what the density would be. Okay, the next bit I'm going to have a little look at is this relative density. Alright, that's quite a common phrase that we use in engineering, and you'll see a similarity between these values here and the relative densities. Okay, so when I talk about relative density, I'm talking about the density of a material in relation to that of water. Okay, so to calculate the relative density of an object, given the actual density, we divide by 1,000. Right, so if you divide 1,000 kilogram meter cubed by 1,000, you get relative density of 1.0. Okay, and we'll go straight down to the bottom here. So to calculate the relative density of gold, we divide that by 1,000. So So we get a relative density of 19.3. So these relative densities here are talking about the density of a material in relation to this base material here. Okay, so bear that in mind, because in some of these questions you're going to be given a relative density and you have to transfer it into an actual density. Alright, and vice versa. So the opposite of dividing would obviously be multiplying. So if I'm given a relative density of 1.3, I multiply that by 1000 and that will give me my actual density of 1030. Okay, so bit of phrase, bit of new terminology for us, but that relative density is always relating back to that of water. Alright, so let's go ahead and we'll use these for the density calculation. Now, I've got a block of some form of material here. I've been given some information in relation to its physical properties, so how big it is and its mass. So I'm going to make a little list of the known values here. So I'm going to go length is equal to 275 millimeters. Width, we'll do length, width and height. So width is 110 millimeters, and then height 0.05. Oh, I'll give that in meters actually. So that should be 50 millimeters, and then the mass is 4.08 kilograms. Okay. Now, if you want to do your volume calculation separately, all right. So we could do volume would be length times width times height. So that would equal, again, what do we need to do to these? We need to turn them into meters, because our units are kilogram meters cubed. So any of these values here must be meters. Okay, must be meters. All right. So we've got 0.275 times 0.11 times 0.05. Okay, and I'll let you pop that in your calculator. And we'll get 1.51 times 10 to the minus 3 meters cubed. Alright, now the more confident amongst you will be able to take that, calculate that straight into your density calculation. So let's go ahead and we'll actually find the first part of this question. So density is equal to mass divided by volume. So I'm going to take my mass, 4.08. I'm going to divide that by my volume, 1.51 times 10 to the minus 3. Okay, as I said, more confident amongst you can take that and put it straight into your volume as your volume calculation. And what we'll get there, again, just pop in your calculator. So we'll get a density of 2,697.5 or thereabouts kilogram meter cubed. Okay, now if you want to transfer that into engineering notation, you hit your ENG button and that will equal 2.70, and I'm doing three significant figures here, 2.70 times 10 to the 3 kilogram meters cubed. Okay, so I've got the answer to my first part of this question. Next part, the relative density, and I'll just do R, I'll put a little d there. Relative density is equal to the actual density, so it'd be 2.70 times 10 to the 3 divided by 1000. Again, you know, you wouldn't necessarily have to write this formula down, but it's always good practice. The relative density here would be 2.70. Okay, no units, because I've got kilogram meters cubed on the top, kilogram meters cubed on the bottom. They cancel. So relative density, no units on that one. One of the only few areas where we don't have any. Okay, now having calculated this density, then we'd probably be able to work out what material that is. All right, and the aluminium is around about that density, so it does fluctuate slightly, but again, densities tend to be approximate because they are very specific to the properties of that material. Okay, right, next one, slightly trickier because we're introducing just a bit more of a complicated volume calculation. So let's make a little list of our known values here. So we've got diameter is equal to 0.06 meters. Okay, so diameter of this sphere, yeah, diameter is 0.06. Okay, now because we know our diameter, we can then calculate our radius, and we'll write that down as well, 0.03 meters. Okay, and then we've got mass is equal to 0.35 kilograms. Okay, so two things we're calculating here. First of all, volume, and then density. It's the only way we can actually do it. We can't calculate the density of this object without knowing its volume. So again, check your formula sheets out for this one, and I'm just going to make a little list of the formulas I'm going to use here. Volume of a sphere, check your formula sheet, 4/3 times pi r cubed, and then I'll stick my density calculation in there, over v. Okay, now as always, check your formula sheets. You'll be given these formulas during any upcoming exams. So the 4/3 is a constant, the pi is a constant, and the cubes are constants. The only thing that ever changes is the radius. So when you can remember that, then these become a little bit clearer. So first part, I'm going to do volume is equal to 4/3 pi times radius cubed, radius, half my diameter, and I'll pop that in some brackets just in case. So I'm going to get an answer, and you'll get, again, don't take my word for it, pop it in your calculator and check it yourself. You get 1.13 times 10 to the minus 4 meters cubed. Now again, hit your ENG button to take it to standard form. ENG, hit your ENG button, and then I'll get 113, I'll do 0.1 because that's what we're getting there, times 10 to the minus 6 meters cubed. Alright, so I've got my volume built in. Next bit, density. Again, rho equals mass divided by volume. So I'm going to go across, I'm going to take my mass, 0.35, divide that by my volume, 113.1 times 10 to the minus 6. So I'm going to get a mass of, so I got 3094.6-ish times 10, oh, no, kilogram, jumping the gun there, kilogram meters cubed. Hit my ENG button, and then I'll get we'll do 3.10 times 10 to the 3 kilogram meters cubed. Okay, and obviously I can get my relative density from that, divide that by 1000, that'll give me 3.1. So I'm just going to make sure I write my answer down in next to where it says answer. So I've got 3.10 times 10 to the 3 kilogram meter cubed. Good habit to get into. Where it says answer, just write your answer next to it. Good, okay. Right. Now, as always, don't forget to check out your workbook for some more density examples, and also there'll be some on Canvas for you. But a little question for you to think about and ponder as you finish this video up. Okay. Now, keep your eye out for any upcoming fluids videos. This is going to be the sort of first in a series of those. But a little question to keep you ticking over. And as always, thanks for watching. And if in doubt, give me a shout, and we'll see you in the next one. All the best. Bye bye.